ladies. We are going to be talking about polynomials today. I kind of changed these notes if you printed them out earlier today. Or yesterday, essentially. So we're going to start off with some vocabulary. What is a polynomial? A polynomial is a monomial or a sum of monomials. When we were doing our exponents, everything we had there was a monomial. So, for example, we'll see it even further here. 3x squared, that is a monomial. It has no addition or subtraction with it, so therefore it's considered a monomial. Then we got a binomial, is a sum of two monomials, and a sum can have negatives, which in turn changes it to subtraction. And then a trinomial is the sum of three monomials. And then we'll get down to polynomials that's more than three terms. We really don't have a specific name. So we'll classify polynomials by the number of terms. And then the degree of the monomial is the sum of exponents of all its variables. So what that means is if I have 3x squared y to the fourth, what is the sum of those exponents? And that would be 6. That would be the degree. The degree of a polynomial is the same as the degree of the monomial term with the highest degree. So we'll see some examples coming up, but always want it to be the highest degree when we classify it. And then the terms of the polynomial are usually arranged from greatest to least degree, and this is called standard form. So all of your answers we would want to have in standard form. Make sure I'm still reading here. Yes, okay. All right, so here we're going to write polynomial in standard form. Just the beginning here, what is the highest degree? That would be this x to the sixth. So that's going to be our first term. And then the next greatest, or, if we're decreasing our exponent number, this would be a positive 4x to the fourth. And then we have that positive 3x and then minus 2. So if you see, it's going in decreasing order from greatest to least. 6, 4, this is a 1 here, and then that would have been a 0 exponent, yeah? Constants are always at the end. So let's go ahead and classify these. We're going to first classify it by its degree. So if we don't have a degree, meaning a constant, that's what it'll be called. Just write it all in the same color. So it's called a constant, monomial maybe, or it's very rare we'll ever have, we won't, a constant binomial, trinomial. That's slightly rare. So some examples of that are basically like -3, 7, it could be 2/3, right? Because essentially, if we remember, that's x to the 0 power. That is why it is a constant. Okay? And I'll put that x to the 0 power back there. So all of these could have x to the 0, yes? So what if the degree is 1? We've seen examples like this. That's like x or 1/2 x, or maybe x plus 7. All of those x's have a degree of 1, so therefore it is linear. Squared, so anything x squared would be quadratic. Again, this is by its degree. So we're only looking at degrees, so I could even have, x squared minus 16. Okay, what if it's x cubed? Or we can have, I'm using x pretty much consistently here, but it can be any variable, y to the third. Or we can do even further, 25 minus x cubed, stuff like that. That is cubic. To the fourth power, that would be quartic. And then to the fifth power, I'm just trying to come up with some fancy ones. That would be quintic. Okay, so on this right here, the highest degree is 5, so therefore it's still quintic. So I could put another example here, or I could get rid of this and put like plus 3x cubed plus 9, anything like that. And then if it's 6 or more, so we can see that as like x to the 6th plus x to the 5th plus 3x to the 4th. And, something like that. Even though it has a 5th degree and a 4th degree, 6 is still the highest. So we just say, whether this here is a trinomial, which we're going to learn next. This trinomial would just be a degree of, and then you fill it in. In this case, this is a degree of 6. But it can be any other number, pretty much all the way to infinity. Okay? So again, that is classifying polynomials by its degree. And now we'll do it as a number of terms. So one term, we've already talked about that, is a monomial. Okay, and that's something like if I do add other variables, xy squared, that's a monomial. Even a, b, c, that is a monomial because there's no addition or subtraction between those terms. So what if I have x to the third plus 7x? That's considered a binomial. And I've probably used binomial, so c minus 8, that's also a binomial. I might have used binomial talking before. Mono is 1, bi is 2, 3 is trinomial. And this should say 4 or more. So the trinomials, again, we could have anything like 5x to the 7th minus 2x to the 5th plus 9, anything. If it's anything given that it's 3 terms. But if I have something of the sort like, I use 3 a lot. Something like this, we can't call it a trinomial, binomial, or monomial. We just call it a polynomial because poly means many, yeah? So that's by the number of terms. So we're going to put those two, we're going to put the degree and terms together, and we'll be able to name or classify any type of polynomial. So let's get at that. First, we're going to write it in standard form and then classify it by its degree and number of terms. So this is not in standard form. Part A here. To get it in standard form, I would need to do greatest to least So I have 3x squared plus 5x minus 7. And I say greatest of least my exponents. Okay, so that's an exponent of 1 there. And if I look at it, I have 3 terms. And then my highest degree is 2. So that is a quadratic. And then we have 1, 2, 3 terms. So a quadratic trinomial. Part B, I need to see what's my highest degree. Well, I have this x to the 4th, but then I have 2 of these guys, 2 of these x cubes. So I would have to combine those. That's going to be plus 4x cubed minus 3x cubed, which will get us a positive x cubed. So I already dealt with this guy. It looks like I dealt with those guys. Then I have squared that I need to take care of. So, and then I need to the first power. There's none of that. So then just our constant on the end. Okay. The highest degree, now that we're in standard form, is 4. So that is a quartic. And then we have 1, 2, 3, 4 terms. So I can't do mono, bi, or tri. So we would have polynomial, quartic polynomial. Okay, this guy here, it's one guy, so monomial for sure. And then the highest power here is only really 3, so it's a cubic, and it's only that one term, so monomial. This last one here, it's not in standard form. So to put it in standard form, I need to start with my highest power, which is 5, and then decrease my exponent size. So that goes 5 to 3. Those are only the 2 terms. So, but the highest degree is 5. That makes this a quintic. And then I have 1, 2 terms, so it's a quintic binomial. Yes? Quartic and quintic don't come up very often, but quadratic and cubic for sure. And linear. We've seen linear already all throughout this year. So now that we know how to classify them, how can I actually add them? So I can add or subtract polynomials. You'll combine basically the like terms. When you're subtracting, you might need to distribute the negative first, then combine like terms. It depends on how you would want to essentially go about doing it, and I will do both ways. Well, not on all of them, but once we get to the subtracting, I'll show you. So when we're adding these, essentially our parentheses just drop because addition does nothing to the polynomial after it. Because if we distribute a positive number, or a positive coefficient there, it's still going to be positive. So you really don't have to rewrite this out. I'm just rewriting it without the parentheses. And then I need to go into standard form. So you can just automatically say, oh, it's addition. So I'm just going to ignore the parentheses. And now I need to find my highest degree. And are there any like terms for that highest degree? So it looks like I have a degree of 0, 4, and 5. So it looks like 5 is my highest. So I have 2m to the 5th plus 8m to the 5th. That's 10m to the 5th. And then I have to the 4th power. So this would be good to have your colors with you. That is negative 16m to the 4th. Because that's negative 10 minus 6. Do I have an m to the 3rd? No. M to 2nd? No. But I do have a constant. Oh, I don't have a linear either. No m to the 1st. But I have this final constant here, 1 minus 8, which is negative 7. And that would be my final answer. I did not ask you to classify it, but it is nice if you can look at it and classify it. This would be a quintic trinomial. Yes? Okay. What if I'm given two variables? So when I have two variables, the variable exponents both must be, well, each exponent must accordingly have the same exponent. So if x to the has a to the 5th power, we're going to have something x to the 5th. So in this case, I'm not going to rewrite it, but I'm going to start off with just doing this guy. And this one's harder in standard form because you have two variables, so I'm not worried about a two-variable polynomial being in standard form as I am with the one-variable ones. So I have 9x to the 5th y. So I need another x to the 5th and y to the 1st. So if I go to my other terms here, it looks like this guy right here. So that's 9x to the 5th plus negative 6x to the 5th. So that would be 3x to the 5th y. I missed that y when I was saying that out loud. So then it looks like I just am going inside of here and looking at the next term. So positive 3y to the 4th. And then I have plus a negative 8y to the 4th, which would be minus 5y to the 4th. And then finally, do these combined here. That's positive 5y to the 5th plus 10y to the 5th, and ensure that is 15y to the 5th. So if you see here, ladies, I do not add any exponents, right? I do not do anything with the exponents besides look at them and combine the terms that have those like exponents. Yes? Okay. Let's move on to another one. So those aren't so bad. Oh, yes, this is a little funky because this would not let me merge these cells on OneNote here. So it'll look funny on the printout, but oh well. Okay, so here we have 3 different types of polynomials. Not a big deal. Let's just take it, browse through it first and see what is the highest degree we have. It looks like it's to the 5th. So I can start off with that. I have negative 10x to the 5th plus 8x to the 5th plus 8x to the 5th. Okay, so I got the fifths, those guys down. And then, so if I want to, I can come down to the bottom here and say, if I do add those together, I'm going to be getting 6x to the 5th. And then I'm going to go to the 4th power. So where are my x to the 4ths? I got this guy here, x to the 4th plus a negative, so 6x to the 4th plus a negative 2x to the 4th, which really is just a big minus, yeah? So 6x to the fourth minus 2x to the fourth would be positive 4x to the fourth. Then I need to do my to the third power. Looks like I have minus 6x to the third plus 10x to the third. So that is positive 4x to the third. And then finally, my x to the seconds. I only got one of them. And there's a positive out here, so it's obviously a positive 10x squared. So I only mentioned that there's a positive outside there because when we start subtracting, you will have to actually use that subtracting symbol. So that's kind of another way of doing it. Instead of rewriting everything, you can use your highlighters and highlight stuff too and not write this down and like do that mentally in your head, like negative 10 plus 8 plus 8. I'm okay with that. Okay? All right. So that's it for addition. Now we're going to find the difference of the following polynomials. So the only difference here is, no pun intended, difference is that we must distribute this negative to everything on the inside of the second polynomial. Now, is it necessary for you to show this distribution? Yes and no. It helps keep you on track. But I've seen some students come in here and just say, oh, everything's going to switch signs. So this becomes negative, that becomes plus, and this becomes negative. But again, this sometimes keeps me in line when I need to. All right, so we scan it, and looks like we have n to the fifth. So that would be my first one, is my highest degree. Oh, well, that cancels out. It does not become 0 n to the fifth. It just becomes 0. All right, so then I would do to the third power next, because there's no fourth power. So 7n to the third minus 8n to the third is negative n to the third. And then finally, my n squares would be 11n squared, because that's 3 plus 8. Really not so bad, right, ladies? I didn't think so. All right. So here, again, it's your preference if you want to distribute that negative. Again, it makes it easier, or you can think about it like this. Say, what do I want to start off with? Let's just start on this left-hand side, this left-hand parentheses. All right, this 3m cubed. Do I have another 3m cubed preceding it? Yeah, I got this guy here. So I have 3m cubed minus 9m cubed. So 3m cubed minus 9m cubed. And that's going to give me a negative 6m cubed. Okay, so let's highlight that in that color. I don't know if that really will make a difference, but we got to make sure we are actually, that's actually subtracting if you do not distribute. So then I'm going to go to this guy. That's m to the fifth, n to the second. So I got another one here. M to the fifth, n to the second, minus m to the fifth, n to the second. Oh, well, that cancels out. So nothing there. So then finally I have this negative m to the fourth, n to the second. but this negative was out here. So that must become a negative times that negative plus m to the fourth n squared. So technically that would have been like 0 in this first set of parentheses, this first polynomial, 0 minus the negative m to the fourth n squared. Yes? All right. Last but not least, got 3 babies here. And since it's only one variable, it's a lot easier to rewrite these things out when it's just one variable. And I've made mistakes, so I'm going to distribute this. I've made mistakes where I don't copy it well enough. So, kind of be careful with that. Yeah, this is supposed to be blacked out. Okay, so I distributed those negatives instead of just going at it, which when there's 3 of them, it's probably not the best idea to do that. You probably should just distribute and then combine like terms. So, man, I've really made most of these, the 5th power is the highest power. I didn't mean to do that, but it looks like this negative 7r to the 5th is our highest power. And then I would want to go to the 4th power. There is no 4th power. So then I want to go to the 3rd power. I got 4r to the 3rd minus 4r to the 3rd minus 8r to the 3rd. That's going to be negative 8r to the 3rd. And then my squares, to the 2nd degree. So I have positive 7r squared minus 5r squared minus 6r squared. Say that's negative 3. Negative 3r squared. Yeah, and that's it. And yeah, we can consider this a quintic trinomial, which, okay, this one did have to the 5th, but on A here, this is actually a cubic binomial. This one over here, I'm not requiring you to know, but if we were to classify it, it would be these two have to add together. So it actually would be a degree of 6, a binomial degree of 6. Okay? So just kind of getting you doing those as well. Being able to just classify. So not so bad. Most of you might have seen this stuff already before, but keeping things organized is definitely most important. And then your homework's posted. Q will be posted probably tomorrow or, because, whatever I had chatted before class. But, all right, have a good rest of your day.